Alright, so if we were going to kind of guess what the length of that arc from 0 to 2 pi is, what would be at least a ballpark of what would
3
be
pi.
3 pi?
Yeah.
3 times pi, so that's like 10. Do you think this is 10, around 10 long? How did you get 3 pi?
I just kind of guessed. You said the ballpark it. What's the question?
It would be
How
twice
long is this right here?
4 pi.
How, do we have an educated guess?
Yeah,
Maybe I
because
should
it's like
ask for an
it's like
educated
twice of a 2 pi. Because there's the curves.
So this is 2 pi, and you'd say,
Each one
if
would
this
be
were a string, it would have to be twice as long to go from around like this.
yes.
Alright, so our guesses. Guess number
Anyone?
1, 3 pi.
I mean, I also did this last
Number
night.
2 is
Wait, did you take
4
it last
4
time?
pi.
I don't have a better guess.
Like if I gave you $1,000 to get within 0.5,
Oh,
how could you figure that out?
Oh boy. Wait, you gave us an equation yesterday. How long do I have?
Oh no! Hey, you do what you can with $1,000, right?
You gave me an equation yesterday. I can use that.
Look at the notes, yeah.
Yeah.
Look at,
7.64.
you get $1,000. That's your guess?
Yep.
That's pretty aggressive. So could we
Oh, yeah.
estimate how far this is?
yes.
If I asked
bring your
a
finger.
third grader, they could estimate how far this is. How would they do it?
You'd go like, you'd rotate. You'd
They
go
take a ruler.
They would take a rular and they would measure from here to here is some length, right? And then they could find this length. And they could find that length. They could find that length. So do you agree that the blue line segments is at least an approximation, right?
So you saying it would just be 4?
Well, is this 1 right here?
I think so.
This is
Oh,
one.
wait, that's a hypotenuse.
And this is pi over
Oh, it's the
2.
square root of 2.
So it'd be the square root of pi over 2 squared plus 1. Okay. But do you understand that the process is you could add up a whole series of line segments? And how could you become more accurate? with
Integrals.
this?
More lines.
More line segments.
So you have
So I could find this one plus this one plus this one plus this one. So if I add it up,
Linearity. Well, that's a summation.
well, how do I find the individual distance of each individual line segment? Okay, you did the distance formula, right? So the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So if we just said I equals from 1 to, we have lots of them, we'll say infinity. And let's say the square root is not x1 minus x2, we'll say it's delta I x of I squared plus delta y sub I squared. Are you kind of with me?
You're doing a bunch of
So this mathematical notation is saying that we're going to systematically add up each individual line segment from 1 to infinity. This is before integrals, so this we could do this without calculus. We would just have to create a whole bunch of them, right? So, yes, our goal is to create an integral, because we don't like the Riemann sum scene, do we? Alright, so how about we change our delta y sub I to be delta y squared over delta x sub I squared times delta x sub I, or x squared. Is this still delta y squared?
Yes.
It is, right? Plus delta x, and I'm just going to get rid of the I, squared. So it's still the same thing. I can factor out a delta x squared, left with 1 plus delta y squared over delta x squared. root. The square root of delta x squared is what?
Delta x.
It's absolute value, but in this case, it would be delta x because it's positive. So that's just delta x, so I can put that at the end. So we have the summation I from 1 to infinity of the square root of 1 plus delta y squared over delta x squared times delta x. So that would become
An integral.
an integral from, let's say, a to b square root of 1 plus the derivative squared dx. So that's your derivative, that's your dx. Okay, so this will tell us the length of a curve. So in this case, we could find the length of sine x. It's probably in your notes, isn't it?
Is that a concept we should know for the AP exam?
I don't.
Oh, good. That's too much algebra.
Okay, so our function is sine x. It's y prime would be cosine x. So we could find this length by integrating the square root of 1 plus cosine x squared dx from 0 to pi. That looks like it's a calculator problem. Is it the 7 point something?
7.64.
Okay, so that's arc length. Do you remember surface area?
We use the arc length times the something else.
Times 2 pi
R, right.
f of x.
Okay,
Which
so
is
this
like
is
pi.
actually easier than the surface area problems. Okay,
Did we win?
that's 7.4. If it asks you to graph the curve to see what it looks like, you can do that if you want to, or you don't have to do that at all.
I'm actually running out of graph paper. Let me get some.
That's it?
Yeah, I don't really have anything. Did we get that far?
No.
Did anyone get that far?
Wait,
I didn't really know the steps that we had to go in.
why'd you make it go under? It's just y to, or just to the 1/2, not the negative 1/2.
Oh yeah. Keep going.
Wow.
That's why I asked. Anybody?
No, I didn't. Didn't get that part.
Slay.
Got it wrong. I forgot to change.
Did anybody get that far?
I don't even think Angel got that far. She just noticed that you messed up.
Well, I mean, I just forgot the 2x. So, other
You forgot the change rule?
Me too.
So, yes.
Was there a point where we got the channel? Yeah, there was.
Yeah, like chapter 3.
Hey, wait a second.
We're
We can
almost
just-
done with
we can-
calculus, huh?
3 days.
We can just get rid of that square.
Oh,
because
what?
it's square root. It'd be x squared
Does that make
times
sense?
x
Well, it makes sense for
x
one.
squared plus.
They will be two things, but not come on one line.
Yes, I got
further?
that far.
No.
I just
I forgot.
Oh.
Yeah.
I don't know what to do now.
I forgot.
Alright, Eric.
What was
You erasing your air filter?
Better than Wilson's.
Any ideas?
You can
I
adapt
simplified.
it.
Factor.
Yay!
X to the fourth plus 2x squared plus 1. What's that factor be?
X squared plus 1 and x squared plus 1. Oh, x squared plus 1 squared.
You were right both things.
Oh.
Yep.
Well, yeah. So then
One
that gets
squared
rid-
equals one.
So if you say a is x squared, then this is a squared plus 2a plus 1. So it's a plus 1 times a plus 1. So it's x squared plus 1. Or x squared plus 1 quantity squared.
X squared plus 1.
Which is just x squared plus 1. So we're now integrating x squared plus 1. It's actually absolute value. From 0 to 3. The absolute value of x squared plus 1 is redundant because it could never be